Welcome to this tutorial in our Ansys Mechanical series. Today, we're going to dive into a practical example that highlights the effect of gravity on a structure. Let's set the stage with our problem statement. We have a steel cantilever beam, 3 meters long, fixed at one end and free at the other. The only load acting on it is its own weight, gravity. Our goal is to determine how much it deflects and what stresses develop. To begin, let's open Ansys Workbench. On your computer, go to the Start menu and search for Workbench. Once you find it, go ahead and launch the Workbench application so we can set up our project. Once Workbench is open, you'll see a toolbox on the left. Find the static structural module, then click and drag it onto the empty project space. This will create our analysis system, ready for us to define geometry and materials. Next, we'll move to the engineering data section. By default, structural steel is already selected as the material. Since we're using a steel beam in this example, we can leave it as is, no changes needed. Now, let's define the geometry. On the project schematic, locate the geometry cell under your static structural system. Right-click on it and choose New Space, Claim Geometry or New Discovery Geometry to open the geometry editor. Once the Discovery Geometry window is open, look for the eye icon in the top toolbar. Click it to switch into the sketching or modeling mode. This will let us start drawing the beam geometry for our cantilever example. Click on the Line tool in the sketching menu. Begin drawing a rough outline of the eye section for the beam. Don't worry about exact sizes yet, just sketch the general shape. We'll add precise dimensions and constraints once the rough geometry is in place. Now, we'll apply geometric constraints. Start by setting the center of the eye section on the origin of the sketch plane. Use horizontal and vertical constraints to align the key edges symmetrically, ensuring the shape is balanced and centered before adding dimensions. Now that the shape is constrained, add the exact dimensions. Set the total height of the eye section to 200 millimeters, the width to 100 millimeters, and the thickness of all segments, the web and flanges, to 10 millimeters. This will define the final shape of our I-beam section. With the sketch complete, select the Pull tool. Click on the eye section profile and pull it along the beam length. Set the extrusion distance to 3000 millimeters, which equals 3 meters, matching the beam length from the problem statement. Now that the geometry is done, you can close the Discovery window. Back in Workbench, right-click on the model cell and choose Edit to open Ansys Mechanical, where we'll set up the simulation. When Ansys Mechanical opens, you'll see that the static structural analysis is already applied by default. Since we have just one part, we can move directly to the next step, generating the mesh so we can prepare for the simulation. Right-click on the mesh option and choose the sweep method since our beam is extruded. For the element count, set 50 elements along the beam length. This should provide a good balance of accuracy and computational efficiency for our gravity load simulation. Set a face sizing of 5 millimeters on the eye section. This will ensure about 2 elements through the thickness. While more accurate analysis typically uses 3 to 5 elements across thickness, 2 elements will keep things simple for demonstration purposes. Now, right-click on Mesh and select Generate Mesh. Ansys will create the mesh based on the sweep method and sizing we applied. Once it's done, you'll see the meshed beam, and we'll be ready to move on to applying boundary conditions. First, we'll apply the fixed support. Select the face at one end of the beam, right-click, and choose Insert Fixed Support. Next, we'll apply gravity. By default, gravity points in the negative z direction. So, Insert a gravity load and set it to -y so that the beam's weight acts downward correctly. With gravity applied, the setup is done. Now, let's add results. In the Solution branch, right-click and insert Total Deformation to see how much the beam deflects. Also, insert equivalent von Mises stress to observe the stress distribution. Once added, we're ready to solve and evaluate the results. Now that everything is ready, simply click the Solve button. Ansys will run the simulation and calculate the deformation and stress results under the gravity load, once the solve is complete. The simulation is now complete, and we can check the results. The maximum deflection at the free end is about 0.65 millimeters. Compare this with the analytical deflection, and you'll see we have a close match. The maximum von Mises stress is around 6 MPa, which is also within expectations. So, that wraps up this tutorial. If you learned something today, don't forget to subscribe to the channel. We've got more simulations coming from structural analyses like this one to fluids and electromagnetics. See you in the next tutorial.